So we've made it to the end of, well, not quite, we made it to week 5, but we've made it to the end of your content. So you've got this dilations, rotations assignment, and you've got another mini quiz that are due up today, or opening up today. So next week, we'll have a review day, and then we'll have the test. So next, what is today? All right, so on Thursday, we won't have synchronous classes. Wait, I'm getting ahead of myself. So rotations and translations. Your assignment looks like this. You can just watch the loading screen. Okay. So you have to find the coordinates for these vertices when you do certain transformations to them. So what you need are these formulas here. So back to semester 1 formulas. 2 things we're focusing on are rotations and dilations. So that's this right here. This black one and this green one. But actually, this green one, we're not going to do the one with the colors in it. We're just going to do the basic one. So really, this is all you need right here. The rotations formula and the dilation formula. So let's go over to some examples. I'm going to pull up this formula again. Okay, so when you do rotations with the points, you can just use these formulas. So 90 degrees is negative b, comma a. 180 degrees is negative a, comma negative b. And really when you put the negative here, you're not actually making it negative, you're just changing the sign. But mathematically, you can just say negative. If it's already negative, you make it positive. Okay, so the answers to these examples here, for 90 degrees, you flip them. So it'll go -7, that marker is too thick. You go -7, comma 5, and then you change the sign of the first one. So that becomes plus. So 7, 5 is the answer when you rotate it 90 degrees. So what's happening here is, here's the original point down here. You rotate it 90 degrees. Well, if this were a sheet of paper, I could just rotate it, but it's not gonna make a difference if I flip my tablet because it'll just rotate. Anyway, so if you rotate 90 degrees, it'll be somewhere about 5. 1, 2, 3, 4, 5, 7, 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. It'd be somewhere about here when you rotate it. If you do this on a sheet of paper, you can literally rotate the paper 90 degrees and it will be that point right there. So let's do these other ones mathematically. For 180 degrees, you keep them in the same order, but you change both signs. So that becomes -5, +7. You don't actually have to write the plus there. And then this last one, you flip them. So -7 goes first and 5 goes second, but you change the sign of the second one. So these will be your answers here. So -7, -5, 7, -5, 7 would be about here. Let me change this color. It'd be about here-ish. And then this one, so that became -7, -5, -7, -5, somewhere about here. Okay, so if you want to see how that works, um, if you look at this other screen, that usually has my face on it, we're looking at this smaller dot here. Um, when you rotate it, I have to think about this because it's backwards. Rotate it 270 degrees. Clockwise. No, that was 90 degrees. So rotate it 270 degrees. It should end up, that was about here. So original, rotate it 90 degrees, rotate it 180 degrees, rotate it 270 degrees. So those are the things we're looking at here. So you can look at it graphically, you can do it with the formula. That's rotations. Okay, with dilations. Dilations are really straightforward because we're just focusing on the ones dilated about the origin. So all you do, dilate by 2, multiply everything by 2. So that'll be -4, 8, -4, -6, 2, and 8. Dilate by half, you'd have -1, 2. You'd have -1, -3 by 2. And then you'd have 1/2 and 2. Let's graph these. So the first one was -4, 8, -4, 6, and then 2, 8. -4, so an 8, 4, 5, 6, 7, 8. I think that's here. And then 2 and 8 here. And then 6 should be here. So when you dilate by 2, this thing doubles in size, and now you have this. Excuse the ugly lines. When you dilate by half, I have the points there. So you dilate this by half. This point here, you cut it in half, so it becomes -1 and 2. This point here, you cut in half, so it becomes half and 2. So here-ish. And then this one you cut in half, so it goes about here. So that is your new shape when you dilate by half. So if you dilate by a number bigger than 1, you get bigger. Dilate by a number smaller than 1, you get smaller. So that is rotations and dilations.